Keysight has introduced a new modulation distortion measurement class for the PNA-X series of vector network analyzers. This new measurement allows the user to make wideband distortion measurements like NPR, ACPR, and EVM on a network analyzer. This approach has many advantages. Because the network analyzer sees the input and output of the device under test with every trace, it can remove the distortion contribution of the test stimulus, giving the most accurate and reliable residual, EVM, and NPR measurements available today. It also gives the user more freedom in choosing a test signal. NPR testing can be done with a traditional notched signal, or with no notch as shown here, or with any wideband signal. EVM is calculated from the overall distortion contribution of the device, so any wideband signal can be used for EVM without a need to know the parameters of the signal or demodulate the signal in any way. The key is the use of spectral correlation to separate the different types of nonlinear distortion. In this screen, you see the yellow trace is the input signal to the device under test, and the green trace is the output signal. The device under test is a small amplifier we're using for this demonstration. From these traces, we can calculate the nonlinear distortion caused by the amplifier, shown as the blue trace. Comparing this distortion to the signal gives us NPR and ACPR values as shown in the table below. Comparing the total distortion power to the signal power will give RMS EVM for the device. But perhaps the biggest advantage is that these measurements can now be made on the same PNA-X that measures all the other parameters of the device under test, such as S parameters, K factors, noise figure, power added efficiency, and many, many others. By adding wideband distortion measurements to this list, we have extended our goal of making all the measurements needed on a component with one connection. Thank you for your time. We will update this video with any new developments.